Hi, in this video, we will continue to talk about R programming. We'll talk about functions. Everything which is done in R is done by functions. And the function in the programming language is very much like its mathematical equivalent. It has some inputs called arguments and an output called the return value. And in R, a function can only return a single object. And of course, this object can contain multiple components. For example, the object can be a vector, a matrix, even a list. It doesn't matter, but as long as it is a single object, it's good. Let's first take a look at the structure of a function in R. Let's check the union function. This is a built-in function in base R. If we type union in the R console without parentheses and any arguments, then we can see the structure of it. So see, it's a function with two arguments called x and y. And in the function, it will first convert x and y to vectors using as.vector function, call them u and v, then use the C function to concatenate them to one vector. And finally, use the unique function to find unique values in the combined vector. So this is exactly what a union operation will do. It will put two sets of items together and only keep the unique items in it. If we want to take a look at the arguments of a function, we can use the args function, args. For example, if we apply the args function on union, you will see the function has two arguments, x and y. And in particular, there are no default values for x and y. And x and y are the argument names. However, we don't have to specify argument names whenever we call a function, because each argument also has a position. If we put the arguments in their correct positions, then we don't need to specify their names. For example, A is a vector of numbers, B is also a vector of numbers. We can just say union A, comma B, then we get the correct result. So this is equivalent to the following line of code. Union x is equal to A, y is equal to B. So exactly the same. However, whenever you use the argument names, you can switch the positions of the arguments. You can say union y equals B, comma, x equals A. Many functions don't require all of the arguments to be specified. For example, if we want to generate 5 observations from the standard normal distribution, we can just say x equals R norm 5. 5 is the number of observations we want to generate. Okay. We get the correct result. We can do so because in the R norm function, the mean and standard deviation have default values. We can check it using the args function. We apply the args function on the R norm function. You see there are 3 arguments, n, mean, and standard deviation. And mean and standard deviation have default values 0 and 1 respectively. So that's why we don't have to specify them. If we omit them when we call the function, then mean will be 0, standard deviation will be 1. But n, the number of observations, does not have a default value. So we have to specify n whenever we call the function. And apparently the union function doesn't have default values for x and y. Let's see. Now let's see how to write functions by ourselves. It's quite simple in R. We just need to use the function. So first, give a name to your own function. For example, I want to create a function to calculate the square of an object. We can just call the function square equals function parentheses, then put all the arguments that are needed in the function in the parentheses. If you have multiple arguments, you need to separate them by commas. Then curly bracket, write down something you need to do in the function. In my simple function, I just need to return the square of x. So just put x squared here. After I define the function, I can immediately call the function. Square root of 5, which is 25. Correct. Just pay attention for self-defined functions. Whenever you want to use it, you need to define it. That's because after you quit R, the function you define will not be saved usually, unless you save the workspace, which is not recommended. Whenever you reopen R, the function you have designed does not exist, so you have to redefine it. So that's why it's important to save your code in a script or some other file so that you can reuse it later. Pay attention that objects or variables which are created inside a function do not exist outside of it. Take a look at this example. I created a function to calculate the mean of a vector. I call it mean2 because in R there is a built-in function called mean. So mean is a reserved word in R. To avoid confusion, I use mean2. So the function will first calculate the length of the vector x and then divide the sum of x by the length of it, which is exactly the mean of it. Okay, so the function works. It seems that m is defined in the function, but m does not exist outside of the function. If you type m in the R console, you will get the following error message. Object m not found. That's because m is an intermediate result in the function and is not recognized outside of the function. Just pay attention to that. Now let's see some examples of writing functions. We have learned conditional flows. Actually, conditional flows are important building blocks of self-defined functions. For example, if we want to create a function to calculate the absolute value of an object, we can do so. Call it abs2. Again, because abs is a built-in function in R, so that's why I name it abs2. And it's a function with only one argument, x. If x is smaller than 0, the output is equal to negative x. Otherwise, out is equal to x. And finally, I will return out. And then the function is done. Then test it. Put negative 5 in the function, we get 5. Now let's see an example of writing a function using loops. Suppose we want to define a function so that we can calculate the factorial of a positive integer. The factorial of a positive integer is the cumulative product from 1 to the integer. For example, 3 factorial is equal to 1 times 2 times 3, which is 6. And 2 factorial will be 1 times 2, which is 2, etc. So let's write a function to calculate it. I call it factorial 2. Again, factorial itself is a built-in function in R. So pay attention, now we assume that the input n is a positive integer. So first out is equal to 1. Then write a for loop. For I in 1 to n, calculate out equals out times I. So let's see how it works. In the first iteration, I is equal to 1. So out is equal to out, which is 1, times 1. So after the first iteration, out is still equal to 1. And in the second iteration, I is equal to 2. Then out is equal to 1 times 2, which is 2. And then in the next iteration, out will be equal to 2 times 3, which is 6. Okay, so the for loop helps us to calculate the cumulative product. And eventually after the last iteration, out will be equal to 1 times 2 times all the way to n, which is exactly what we need. Let's test it. Factorial 2, 5 is equal to 120, which is correct. Okay, you can verify it using a calculator. In the previous example, we assume the input is a valid input, which means n is a positive integer. What if n is not a positive integer? In this case, we need to use an if-else conditional flow to filter out invalid inputs. And if the input is invalid, we should provide an error message to remind the user that your input is not correct. So we can do the following. If class is equal to numeric, so it's a number, and round n is equal to n. So this guarantees that is an integer, and n is positive. If all of these three conditions are true, then we calculate the cumulative product and return out. Otherwise, print an error message. The input should be a positive integer. Let's test it. When n is 5, we get a regular result. When n is not an integer but positive, we get the error message. When n is negative, we also get an error message. Great. How about n is equal to 0 case? We know that 0 factorial by definition is equal to 1. And our previous function cannot handle n is equal to 0 case, actually. It only accepts positive integers. So to accept 0, we need another layer of if-else. We can do the following. If n is equal to 0, out is equal to 1, I return out. Because by definition, 0 factorial is equal to 1. And else if we check the three conditions, so this will handle the positive integer case. We'll calculate the cumulative product. And if any of these three conditions is false, then print the error message. Let's check the result. When n is equal to 0, we get 1. When n is equal to 3, we get 3 factorial, which is 6. When n is negative, we get the error message. And if n is actually a character string, then we also get an error message. Alright, that's all for this video. In the next video, we'll talk about the apply family of functions. They are very efficient functions that we can use to do data management, data summary, etc. Thanks for watching. See you next time.